The board? Yeah, that's the one that said.
Oh, okay.
I'm running right from the door. Get ready to speak. And then that comes the other one, the open target round. No, the Dutch red one.
No, those are those ones that were like lighter.
Well, and then this one's really shiny. We just have that shit.
I hate it.
It's what it's that shit is so sweet. It's the best thing to do.
Nothing worse when it's soft.
Yeah, it's soft. That's good. The dark red one, the yellow one. The yellow.
I like my banana flavor.
No,
Not like green, but like.
yeah, it's perfect. Yeah. We got 14 minutes until we can leave. Oh, he's here. Shh, don't ruin it for him. Let us get our hopes up in the club.
Yeah. I think he just enjoys watching class react like that.
Probably.
Oh, nothing too much, just running late today, apparently.
A whopping 2 minutes. It's a whopping 2 minutes late.
I'm really sick. No one actually left. I did some lectures where my voice barely projected. Got too much work to do. I'm not trying. Just wanted all the stragglers to feel like they got to class on time. That was so quiet. He's waiting for me to fill that space. You'll come, don't you worry. Let's talk about this real quick. Right, you got an email from me, you got a Canvas announcement from me. Right, that said something like this. That sound familiar? Right? So it's an advising party, so that just means that we'll have counselors available and faculty available to talk about, you know, what other computer science classes that you should take, to figure out what it is that you're trying to do, and help you get going. So that's next Wednesday. There is a link, so please RSVP if you're going to go. That lets us know how much food you should have, because therell be food and drink, and also helps you get an appointment with the counselor.
You know when, sorry, RSVP, you know when those,
I do not know. Probably Tasha. But Tasha's going to come up with the right person. So you go ask her. Or I can find out. We'll never know. But yeah, it'll be 4 to 6 here in the hallway, and then the 2 classes are actually on the other side of the hallway. If you come at 5, that's fine, but 4 to 6 is when people will be available to come. Any questions on that? No, we good there? All right. Let's do all this fun stuff. So, last class, we talked about programming paradigms, but really we got into what programming paradigm? What was the one that we're going to start doing?
Object-oriented.
Object-oriented, right? Good. And so with objects, we said that they have behaviors and they have, remember the other one? Attributes, right? Attributes are variables, right? So we learned structures and how we can group, right, data together in a structure, right? Today, we're going to learn class syntax, so not only will we have attributes, variables, we'll also have behaviors. So we said last class that behaviors show up as functions in C++. So we'll learn today what functions are, and then we'll write some functions in a class-based environment to kind of get an idea of how these things interact. That's kind of what we have on our plate. It's just to talk about what functions are and then get into class syntax. All right, so we're going to create some objects today, some blueprints, class are blueprints, right? So we'll create some blueprints for objects, make some objects, and then get into lab, where I'll kind of help you along in the lab to get what we need to go. Remember, a lot of what we're learning is just going to take a little bit of time and some repetition to get used to the way that we organize our code. So the more we can practice it, which we're going to do every single class for the next couple of weeks, the better off that we're going. You have questions before we get going? All right, let's talk about the first 2 things before we get into class syntax. All right, so I didn't have any questions because your question starts like this. I want you in your head to sum all the numbers from 1 to 200. All right, so you have to do it in your head. You can't use pen or paper. You're going to get 30 seconds to do that. All right, it's like 1 plus 2 plus 3. If you did that slow, you're probably not going to make it. All right? No, too bad. We're going. All right.
Oh my God.
The timer's going.
I'm up to 10.
trying to mentally calculate.
Get it in your head. Oh, 5, 4, 3, 2, 1. Time's up. Anyone get the right answer?
1,000?
39,000?
No, not 39,000.
Is it 1,000?
Not 1,000.
900? What?
Which is the right answer, 20,100. We'll talk about how he got it. He's just really, really smart.
Yep.
Stop in your head.
What about it? He got it. He was talking out loud. He got it, right? I knew it just gave up. Right? I think that would have been me, like, nah, screw this, I don't want to do this, right? It's going to give me the answer, so why does it really matter if I do it or not, right? Anyone try to, like, brute force it? I kind of got to, like trying to find a pattern somewhere where you're like, all right, well, it's 3, and then it's 6, and then it's 10, and 15, and right? So, just attacking it, right, this brute force attempt, 1 plus 2 plus 3 plus 4 is not going to work, right, as the numbers get larger. 1 to 200, right? Those aren't huge numbers, but even still, that's a pretty large problem to do. And so when a lot of times when we look at programming problems, we have to look at this idea of decomposition. Decomposition is breaking down a big problem into smaller subproblems, right? Just like things decompose, right? They break down from one big thing to smaller. So decomposition is the process of breaking these things down, right? And so let's look at how we can break down the sum 2 problem, right? So the brute force way is what? 1 plus 2 plus 3 plus 4, right? And eventually you add all those together, you'll get to 200, right? What the sum of 1 and 200 is. Agreed? Anyone have another way?
200 times 1 plus 200 divided by 2.
I heard 200 times, what did you say?
So it's going to be a fraction. On top of the fraction is 1.
You said 1 plus 200?
Divided, and the bottom is divided. You only divide the second part.
Something like that?
Yeah.
All right. So the question is, how do we get to that, right? And how we get to that is kind of looking at attacking our problem in a different way. Right? Instead of breaking it down into one number plus one number plus one number, let's look at adding the ends together. Right? So if I'm adding the ends together, the first end is 1 and the other half of the end is what? 200. When I add those together, what do I get? All right. And then the next number would be what? 2, and the next number would be? 189. Right? And I get what? No?
201.
201, right? If I do a 3 and I do a 198, I also get what?
201.
201, right? So you'll notice that when I add the ends together, I always get the same number, all right? Which is one more than whatever number I started with. Does that make sense? All right? So I add them together, right, and I get that. All right, the pattern is what?
One side increases, one side decreases.
Right, one side increases, one side decreases, which gives me a bunch of pairs that are all 201. And how many of those pairs do I get? I don't get 200 pairs. How many pairs do I get?
Oh, 100.
Yeah, 100, right? So I get 100 pairs of what? Of 201, right? 100 pairs of 201. So 100 pairs of 201, which gives me what? 20,100. Does that make sense a little bit?
Yeah.
Right? So I get that, right? Last pair, right? If I kept doing this, last pair would have been 101 and 100. Right? Yeah, those together, once again, you get 201. You have 100 pairs of 201. Okay? So the decomposition is taking this large problem and breaking it down into these smaller problems that I can then kind of generalize. Make sense a little bit? Right? Let's bring in the other idea that we're going to talk about, and that's the idea of abstraction. Abstraction allows you to pull out differences in problems to make the solution work for lots of problems. Right? This answer only works for when I'm summing from what? 1 to 200, right? The solution only works for 1 to 200, right? And what I can do is I can abstract out the fact that I'm doing it for 200 and try to put in variables in its place to allow for numbers of, well, allow for any number. Okay. Right? 7 to 200 was what? 100 times 201. Right? If I was going to sum to 10, it would be what? 5 times 11. Right? If I sum to some larger number, right, 2,000, it would be what? 1,000 times 201, right? And so the pattern becomes what? I wanted to abstract it out. What is my pattern? N over 2 times what? N plus 1, right? 200 divided by 2 is 100, and 200 plus 1 is 201. 100 times 201. Right? It's going to work for any number that I'm going to do. Right? So decomposition breaks my problem down into smaller pieces. Abstraction makes the solution work not just for the one, right, problem set, but for all problem sets. That makes sense a little bit? I'm going to kind of go through these ideas. Decomposition, right? That one should make sense. It decomposes, right? Breaks down. Right? Abstraction says take away the specific details and work on a general solution to our problem. Pretty cool, makes sense? we did that. Right. If in code, right, how would I write this in code? Not too hard, right, because it's mostly written.
Yeah.
Right? You just figure out, right, I have some sum, right, that gets assigned that, right? Assuming I already have int in declared, right, just give it a value and then see out sum. I can get myself in that frame, right? But if I said int n equals 200, right, and then I see out in sum, does that work?
Yeah.
Now, if I wanted to do it for any other number, what would I do?
Change the value of n.
Change the value of n. Does that make sense? If I wanted to do it for any number, I would just change the value of n. Okay, what if I wanted to do it twice? Like, what if I wanted to sum to 200 and then also in my program sum to 1,000? What would I have to do?
Make a class or whatever.
Well, we don't know how to make classes. All right. What would I do right now if I wanted to do this twice?
Store in a function.
I like your thinking. So I'd have to use different variables, right?
What if you just did a loop?
So I could do a loop, right? A loop allows me to loop code X amount of time. So I could do a loop, right? But the problem with a loop, and a loop would work, the problem with a loop is that the code has to be like in succession, right? Because you're looping the same code. So if I wanted to sum to a bunch of numbers all at the same time, then a loop is where I would do it, right? Because I could sum once and then sum again and then sum again. But if I wanted to, let's say, at the top of my program, sum to a number, and then do a bunch of stuff, and then later on sum to a number, right? A loop's not going to work, so I don't want to do all the middle stuff.
You'd have to be able to call that function whenever you want.
We don't know that function. That's what we're doing.
Okay.
So really, right now, what I have to do, I just have to copy and paste the code.
Yep.
Right? Take the code that works, copy it, and paste it somewhere else. And copy and pasting is not a good idea with your code. Like, copy and pasting is actually a really bad idea with your code. All I'm going to teach you today, the only time that you should ever copy and paste. So I'll teach that to you today, but you should never copy and paste your own code from one place to another for a myriad of reasons that way. Right. Here's another problem. We're going to figure out an algorithm. I'm actually making you think today. Hopefully that's okay.
It's not.
We have to do it every once in a while. So I want you
It's part
to
of the
think
curriculum.
about what would the algorithm be to calculate exponents. Right, by exponents I mean things like 2 to the 5th or 3 to the 10th, right, so on and so forth. Right, and so what I want you to do is I want you to go ahead and work on that. Feel free to work with a partner. If you don't like anybody, work by yourself, I guess. Right, but take a couple minutes and kind of flesh out what you think that algorithm would look like. Right, how would we write it in code? Sometimes when you're working on algorithms, it's nice to look at a concrete example. So if you want, you could write the algorithm to figure out what 2 to the 5th is. Right, if you want to figure out what that is. Right? But you can't just say take 2 and raise it to the power of 5. That's not your algorithm. Right? Your algorithm is in code. Right? How would I kind of write code that would do that? Right? So I'll give you 2 minutes. That's 4 times as long as the sum takes. Right? So give you 2 minutes to figure it out.
In C++, you could use that arrow, yeah. But and as an
Let's
out,
write it on paper so we can see it.
yeah.
I'm just going to start because I can't feel it. Okay. So if you wanted any number to be able to be this number to an exponent.
Right. It should kind of take it. But if you want to just make it to only be 2 to the 5th, then that's fine. I'm going to write my example to be just 2 to the 5th.
Okay.
Right?
Okay,
That's
let's
like
just take.
decomposition, break that down, and then abstracting it would be.
Let's take n to the. So it's this way to the e.
Yeah.
So look, we could just say,
Assign the value of n and e.
let's just say exponent equals n to the e. So we would just do n equals whatever value, and then e equals 5. Oh, sorry, yes. So then that's our variable name. We call that. So then you would just go exponent. Like that, right? Or is there no parenthesis?
In the parentheses, you can assign the values of n and e, right?
Maybe.
I don't know that would work. You would have to declare n and e. Oh, you already did.
No, I did hear you.
Oh,
Oh, yes, you're right.
Oh.
Do you see
Yeah.
what I'm trying to do?
you don't put it in parentheses though. You just put exponent.
Yeah, it's not this. It's this.
But what kind of type is the exponent?
No, exponent's the variable.
Yeah, I know. But oh yeah, okay.
Wait, so would this? Yeah, so you just name and give it that.
I don't know how long I gave you, but I'm ready to come back. 3 minutes. Yeah, I gave you an extra minute. All right. Anyone have an idea? Anyone want to? N times N times N? We don't know how many of those you have, right? N number of times, right? But by itself. So 2 to the 5th, 2 times 2 is 4, times 5 is 20. So 2 to the 5th is really a lot of protein.
Oh, some huge number.
This is 32.
Oh.
But yeah.
Similar to your last thing, you could just label that variable exponent and put the equation n to the e, and then give your values n and e, and it'll always n to the caret of e.
But
And then it works for any number.
right, but caret is not a character in C++ that we can use. That doesn't exist.
Oh, we can't use that
No.
operator? Okay.
No. You have to break down what is an exponent. How do you do it?
Could you use a for loop?
Okay, good, right? We're gonna need a loop, right? Because we're gonna loop basically, right, 2 multiplying by itself how many times?
Yeah.
5, right? So I'm gonna need a loop. Good. So we'll need a loop. Right, and I'm gonna hard code mine. I don't know where that went. We're gonna hard code mine for the fact that it's 2 to the 5th,
Yep.
and then we'll abstract away that 5, right? If I want to loop 5 times, it's either I equals 0, I less than 5, or I equals 1, I less than or equal to 5. Right?
That's not-
I started 0 for 2 reasons. 1, I don't have to put the equal sign, so that's one less character I have to type. And 2, later on this semester, we're going to start doing our loops at 0 for a good reason. So it's just fitting it in that practice.
So int I equals 0.
Int I equals what?
0.
0. Right? I is less than what?
5.
Because I want to loop 5 times, and I is going to go up what? Just by 1 every time.
Yeah.
Is that how my board gets all crazy? It might fall on me sometimes.
You have it
guys can
coming?
just sit there and laugh for a little while. All right, so I have a loop. Now, what the crap do I need to do in my loop?
What the crap?
Okay.
Right, so should we say like int answer? How does that sound? Get a variable?
Yep.
Right, so what does the answer equal?
Oh my god.
And answer equals 2 times 2, right? Or so that way it's timesing by itself.
2 times 2?
So it's timesing by itself 5 times, which
Right,
is
in the
32.
first loop, they'll say 2 times 2 is 4, it'll store it an answer, right? The next time it loops, they'll do 2 times 2, which is 4, and store it an answer. So if you're gonna loop it 5 times, the answer will be what?
I see.
Nice.
Or answer times equals 2?
Yeah, I can shorten it,
Yeah.
right? Is that gonna work? Should we see?
Yeah,
Right,
that'll work.
So,
First iteration.
right, the answer is 2, everyone agree?
Mm-hmm.
Right, first iteration, 0 is less than 5, yeah?
Yeah.
2 times answer, which is 2 is?
4.
4 goes into answer, so answer is?
4.
4, right? And that was when I was 0, agreed?
Yeah.
Then I becomes what?
1.
1. 4 times 2 is? 8. Right, then I becomes? 2. 2 times 8 is? I becomes? 3. 16 times 2 is?
Oh shit.
Right, I
We
becomes?
done messed up.
Uh-oh.
We done messed up.
Right. 64. Then I becomes 5, and is 5 less than 5? No, so I'm so close. Right? It would have been really easy to find your answer, like the problem, if I had said take, right, not 2 to the 5th, but take 2 to the 1, or 2 to the 0. right? Because 2 to the 0, would this loop ever run? No, but 2 to the 0's answer should be what? 1. So when you don't, your loop doesn't run, your answer is what? 1. Which means your answer has to start at 1. So you're so close. All right, you start at 1.
It's so weird.
Or you could just change I as less than 4.
Doesn't work with like, you know, we're doing integers, so you can't do fractional exponents. We're not doing negative exponents. We're just doing whole 0 or positive exponents. And we're good.
1 over 2 to the 5th.
You changed the answer to 1, but couldn't you also just loop it 4 times instead of 5 times?
Yeah, well, what if it was 2 to the 0? Now I want to get that answer.
Oh, yeah.
Okay. But otherwise, you'd be real close. Is that our answer? Are we smart?
I guess.
Yeah, sure, why not, right? And so a lot of times after you break a problem down, then the question is, how do you abstract, right? And so what changes from problem to problem? What numbers? The 2 changes from problem to problem.
The base and the exponent.
Right, and then the exponent changes from problem to problem, right? And so you would replace those with variables, right? And then it should work for kind of anything. Agreed? Once again, you run into the problem though, if I want to calculate exponents in lots of different places in my code, which you think about it, probably happens, right? You have some formula, someplace that has an exponent, and then in some other weird formula you have the exponent, right? So they're not in succession. So I can't do a loop. So what am I forced to do right now? Copy and paste, right? The worst part about copy and pasting is that if there's a problem here that I didn't realize, let's say that, right, the problem that we had, if I thought it was good and I copy and pasted, right, then
You have 2 times the
you have
back
2 times the errors, or if I copy and pasted 5 times, guess how many errors I have? 5 more, right? So copy and pasting is a terrible thing to do with your code. And so we're going to learn today how to not copy and paste, but write these things called functions. So my abstraction, my decomposition is going to happen via these things called functions. Right, so functions allow us to kind of write commands that do something, which is pretty cool. Right, so I might be able to write the command sum to 200. Right, and this will become, right, the summing of numbers from 1 to 200. Right, basically think of this becoming 20,100. Right, or maybe I might say raise to power 2 comma 5. Right, take 2 to the 5th. Right, get the answer 32, and that becomes that. So we're going to be able to take, right, chunks of code, right, blocks of code, and make them become these commands that I can use and call in main. Okay, does that make sense? Now we're going to attach these functions to objects. Right, remember objects have behaviors and attributes. And once we attach them to objects, then they can act on all of the object's values, which will end up becoming really cool and really useful. Questions on that? We good there? All right, why do functions besides the fact that I'm just going to make you do them? All right, one, it makes your code more readable, right? Copy and pasting code 10 times makes your code longer. It makes it harder to read, right? Otherwise, you could say, right, you say this one piece of code does this one thing. It makes it a lot more readable. So readability is useful for functions, right? Easier to maintain because, once again, you're only fixing problems in one place, not 5 places, 10 places. Right, and then it makes it easier for you to reuse your code, or even better, someone else to reuse your code, right? Someone else can use your raise to power function, right, and do that command and get the right. That makes sense? Any other questions on any of this? All right, you want to get into what it looks like?
Yeah.
Well, we're going to hold out a little bit. We're going to start class syntax, but I'm not going to give you the function syntax yet. We'll do that here real soon. Class syntax looks a heck of a lot like structure syntax. Class syntax, structure syntax, they pretty much look exactly the same. The only difference is we said structures only have data, attributes, whereas classes have data, attributes, and functions, which are
Amazing.
right, they're amazing. And also called. So they can have those member variables, the attributes, and they can have, right, the member functions, which are the behaviors. See, that's what I'm going to start calling them members. All right, classes have members, whether they be member variables or whether they be member functions. Right, they have members. The class is like this exclusive club that you have to be members to in order to do stuff.
So a function is a behavior and a member?
Yes.
Got it.
And an attribute is a variable is an attribute and a member. So we'll call them member variables and members. All members have access to all other members. That's the big key.
Because you can have functions that are not part of a.
Yes. But we're not gonna talk about those for long.
Okay.
All right, don't forget, if you did, then I'll remind you that classes are the blueprints for our objects, right? Classes are not where we store data. I'm trying to stress this point. Classes are not where we store data, right? Classes allow us to create objects, and those objects follow the blueprint of the class, and that's where we store our data.
So you can make multiple of them with different
Multiple
values.
objects of the same class type, right? Which is very useful. Right, don't forget, objects are an instance of a class, right? So let's make a class that'll interact kind of with these raised to power and sum to functions, right? So we're going to start with a very simple class. Notice it starts with the keyword class as opposed to keyword struct, right? After that comes the name of my class, just like before. After that was the name of my structure, right? Once again, first letter capitalized, just to differentiate it between other things that we create, right? Class math. Math becomes a user-defined type, right? Type being a keyword for what? Int, double, char, string, bool. And now I have int, double, char, string, bool, and not struct, but
Math.
math. I have math, right? So that is a sixth type that I can now use in my program, right? Just like I can create a variable of type int, I can now create a variable of type
Math.
math. That variable is called a what?
Class. Or wait.
Called an object.
Object.
Or an instance. Right? But it really is a variable, but we just call it something special because it is something. All right. We have this mystery word, public, that we'll talk about next week. Yeah, we'll come back next week.
Oh, great.
It's gonna show us and then move on.
It's like my TV
So you
show all
don't
over
put that
again.
mystery word there, it's not gonna work. So you just need the mystery word for now. Okay? Another mystery word I will teach you later today, right? So you'll have to stay awake for the lecture to figure out what the void mystery word
That's the function one.
right? And then this is the name of my behavior, so that's a function. You'll notice that functions always end with what?
Parentheses.
Parentheses.
For your
okay?
parameters.
So if you ever want to differentiate
You are
between
right,
a
Chris.
variable and a function, you look for parentheses. Okay? The next two things are what we call member names. Okay? They look like variables. Remember, just like structures, they look like variables, but are they variables?
No.
Because they are the blueprint. But when I create an object, they will have these two attributes, right? And that's where I'll store them. You notice, what did I do to my member names? I added something to them.
You added underscore.
Underscores at the end. Everyone see that?
Yeah.
That is a visual clue to us that it's a member, right? The underscore variables will be member variables. They will be accessed by all of our member functions. Okay, so things are going to look a little bit different because normally we create a variable and name and then we use it, right? With classes, we're going to kind of declare the variable in the class, and then we'll just use it in a function in a totally different place. You don't have to recreate it, it exists. That creates, right, my attributes that I can then use other places.
And this all goes above.
This is all in above name. Eventually, we'll put them in their own files. But not until we get crazy. All right. Questions so far? Don't forget, in class syntax and structure syntax, there's always a semicolon at the end. All right, class syntax, structure syntax has that semicolon at the end of a curly. The only place you ever put a semicolon in the curly is that structure or initialization syntax, like the curly brace syntax, to do that. You don't put it at the end of if statements or loops or anything like that, right? No semicolon at the end of a curly brace, right, except for class structure syntax.
It's not at the end of a do while because the do while ends in parens, right?
Yeah.
So that means
The do while says do, close curly, while open paren, close paren, semicolon. So we're talking about when it's right, when they're butting up next to each other. This is pretty much the only place that will happen. So if you see yourself butting up semicolons to curly braces, you're probably doing something wrong. Will it compile? Yeah, right? Because they'll compile because it just treats it as an empty statement. But you'll get ready to do it. First by me and then by other people. Okay. Sound good?
Great.
All right. These notes are probably what I said. It's semicolon uppercase. Yeah, we did that. Public is special. All right. We call this void output current value. We call that a member function declaration. You hear me say it's a member function declaration. You also hear me call it a member function prototype. those two words are used interchangeably. I don't know which one your book uses, but they're used interchangeably. So sometimes I'll call it a prototype, sometimes I'll call it a declaration, and I'll do that just to confuse.
Yay.
That's not the real.
But you can call things as a prototype differently, right?
Yeah, prototype in itself could be construed as something different. Just like structures, when I create an object of type math, then I use the dot operator to access the members. Whether I take members because they could be member variables now, or they could be member
Function,
functions, like it be,
which is a behavior.
this is behavior, and you guys are listening, right? An object is an instance of a class, which means that we create it using the type and then an identifier, right? So math object, right? This says create me, right? An object whose type is math. So create me an object who has the behaviors and attributes of the blueprint that is the class math.
Makes
Right? So what we're going to get is we're going to get this
That makes way
variable
more sense.
called math, well, whose type is math, right? Its name is math object, right? It had two attributes, right? It had value underscore
Something underscore something.
and extra input underscore,
Yeah.
right? Those are the only two attributes, and then it had one behavior. Anyone remember what that behavior was? It was void something, right? Output, current, values.
Yeah.
Right? And so what you'll see is that every time I create an object, it has the two attributes and all the behaviors of the class blueprint. Right? Those came because, right, on the last page, we said that, right? We're saying that this is what objects of type math look like. Right? It's a blueprint. We're saying this is not what it is, it's not an object, this is what these objects should look like.
Okay, two questions, but they're kind of the same for both sides. Does void always go on top when you're writing in public like that?
Not always.
Okay, so it doesn't matter that you're doing value
Like
and
void
extra
here.
input. That's not how the computer's doing it. It's all kind of at once.
I just want to stress the point, right? I can make another object, right? We'll call it other object, whose type could be math, right? That also has a value underscore, an extra input underscore, right? And a what?
Output current value, and that's got for and yeah.
Right? Does that make sense? Both objects have the same attributes and they have the same behaviors because they are both of the same type. Okay.
So you would put the values for value and extra input inside the parentheses with the comma of output current value?
Yeah.
No? Okay, that's different.
Yeah, we'll get there. That's all next week.
Okay.
We got too much to do. All right, we're doing all this, yeah. So there's my object, right? So access the dot operator, right? So if I say math object dot output, that should be output current values. What a typo, I'll fix it. That should say output current values, right? That would run this behavior, right? We haven't said what that behavior is, but that would run that behavior, right? Or I could say math object dot value underscore gets assigned 5, which says take the value 5 and store it into the value underscore attribute of what?
The math object.
Right? So we put 5 as the value of the value underscore attribute of that object. Right? Notice, did this other object get a value? No, right? Because which object am I working on? Math object. Right? One of the keys of object-oriented programming is that you can have lots of objects, right? Each object has its own, what do we call it? Each object has its own. Sound good? Should we write this?
Yeah.
Why not? Let's do it. You guys got nothing better to do.
Shit, I want to get good at this. Are you kidding me? That's all I want to do. We're on what, 10 now?
Yeah.
Which one did you open?
I'm opening up math.cpp.
Wait, that's not in here.
What?
We don't have
Well,
that
I'm
one.
writing from scratch. You can look at, if you go into today's lectures, it would be, This would be class complete. I'm gonna start from scratch.
Okay.
I like to type along sometimes better. Right? So, let's get our includes IO stream
Well, I kind of want to type from scratch.
using std cout, using std cin, using std inval.
Title this now.
Right, and then we know that we have int main. What gives us a return 0. Right. It's good every once in a while to actually write it as opposed to just copy and paste it. It helps us remember where we know we are. Now, if I want to create my class declaration for the math class, where do I put it?
Before int main.
Above main, right? So before int main, but kind of after our using statements, right? Just in case they use one of those things, right? And so to create a class called math, the keyword I use is
Class.
class, and then I call it something, right? In this case, math.
Yep.
Right? My suggestion is after that, do your curlies and then throw that semicolon at the bottom. Then you're not worried if you have an open and closing curly, and you're not worried if you have that semicolon. I'm going to write the member function declaration. Right, and this would be the behavior. Right, and then later on, I'm going to write the member names declaration. Right, and these would be actions. Once again, we're going to get into this. I'm just going to put there output current value. All right, we're going to talk about that, but we do know how to create member variables, right? So int value underscore, right? Int extra. We are creating the blueprint. We are saying this is what math objects should look like. And all math objects will look this way, right? All math objects will look this way. They will all have a function called output current values. They will all have two member variables called value underscore and action. That makes sense? So the public doesn't matter? It does matter. If I didn't do public, then we're going to get a weird error message. So let me slap that.
And that's like the first line you put in, right?
Yeah, public. And we'll talk about it, but not now. First rule of public is you don't talk about it.
I thought it was Fight Club.
Oh, okay.
Let's tell next one. Anyway, that movie's old now. Anyway, it's like that movie didn't exist. You're like, no, actually, I wanted to know what movie that was. I'm not gonna tell you. Main is right now is where we create variables, where we do stuff, right? And so if I want to create an object of type math, I make it in main. Right? I make that distinction because now we're going to start getting these other pieces of code outside of main. Right? But most of what we do is inside of main. Right? So inside of main, I could say math, right? Because that's my new type. Right? Remember, if I want to create a variable, I could say int x, right? Type identifier. Right? But here I want to say what? Math. That's my new type. And then I'm just going to call it the math object. Right? The type is math. The name of the object is math object, right? Which basically creates me an object like this. Right? Two attributes, one behavior. Right? And I can do things like math object, right? Dot value underscore equals 42. Right? I can do math object dot extra input, right, is 0. Right? If on line 9, if I defined what that function is supposed to do, I can call it. Calling it would be saying math object dot output current value. We're gonna get to that here in a minute, but not yet. All right. I talked about this last class, but can I see out my math object? Am I allowed to do this?
I don't think so.
Do we remind ourselves? No. Like, no, let's not remind ourselves. We know it doesn't work, right? We get this error message, right? Well, what does that say? It says cannot bind std ostream L value to std basic ostream, right? Which to us just sounds like gibberish, right? But what it's basically saying is that C++ does not know what a math object is, so it can't interpret when you output it, what is that supposed to look like? Is it supposed to say 42, comma 0? Is it supposed to say 42 on one line and 0 on another line? Right? It has no idea what that means. Right? So it can't output it. Right? If I want to output stuff, I have to actually go directly to the attribute, right? Math object dot value under. Right? If I run that one, then I should see 42. Right? So I can't output the object itself, but I can output the pieces of the object. Because value underscore is of what type?
Integer.
Integer. Do we know how to output integers?
Yep.
Yeah, right? So we can output anything we know how to output, but it won't know how to output things we don't know how to output. That makes sense a little bit? All right. Should we get into how we write our function?
Yes,
Can we handle it?
Finally.
I have 5 minutes to talk about it. No, I'm going to talk longer. Don't worry, it'll be good. Yeah, we did all that. All right, let's talk about member functions. Right, member functions are the behaviors of our class, right? Most of the time, member functions act on the attributes of the class, right? I said last class that a lot of times the behaviors of objects change the state of the object. Right, and the state is stored in my attributes, right? So a lot of times the member functions, the behaviors, change the values of the member variable. Does that make sense? Right, so we'll see how that happens here. Right? These functions can do a lot of things, right? They can get input from the user, they can calculate data, right? They can display the data. There's a lot of different things we can do with these functions. Right? But a lot of times these functions do one thing, and they do that well. Right, so I'm not going to write a function that obtains input and outputs. I'm going to break it down, right, the decomposition. I'm going to break the problem down into this thing only does one thing, it does input, and it does it really well. And this thing only does output, and it does it really well, right? This thing calculates exponents, that's all it does. And it does it really well. All right? And so these functions allow us to manipulate the attributes of our class object. Right? Functions can return a value. Basically what that means is that functions can produce a value, right? The sum2 function could produce a value, right? The raised to power function could produce a value, they probably should, right? There's also functions that don't produce values, they do something, like maybe they output, or maybe they get input, but they don't need to produce a value, they just get it or they output it, right? Those functions are called void functions. That's where that word void comes in. I told you, if you stayed awake, that we would talk about void. Right? So void functions are functions that they do something, but they don't necessarily produce a value. Void saying they don't produce a value. Okay? As opposed to other functions. So our program starts where?
At the top. Well, we'll start doing stuff in int main.
In int main, right? Int main, and then a what? An open paren and a curly paren, right? And if you have a type and a name and an open and closing paren, guess what you have?
Function.
You have a function, right? So main's a function. It's not void though, it produces a value. What type of value does it produce?
0.
Well, an integer, right? So a lot of times, right, at the end of it, we say return what?
0.
0, meaning the value that function produced was
Nothing.
0. All right. So we'll get to that more next class. Member functions, because they're members, right? They belong to a particular class, right? So my output current values function is part of the math class. You can have other functions that are part of other classes, right? The turn car on function is part of the car function. All right, does that make sense a little bit? Right? They're all part of their own class. That being said, though, we need some way to say that this function is part of this class. And so I'll teach you the syntax to do that. Right, and we'll see what that looks like. Right, so if I still have my math class, which I do, right, I could write the function. This is called the function definition. So we have the function declaration above main, and now we're going to write this definition of it below main, and I'll show you where it goes. Right, it looks a lot like the function declaration with a couple new things. One new thing, math colon. Right, that's one new thing that wasn't there before. Right, and basically what I'm saying is the output current values function is part of the math class, right? So the 2 colons means is part of, right? And then obviously the math means is part of the math class. The other thing I did is that before it just had a semicolon at the end of it, right? And now instead of a semicolon, it has what?
Curly.
Curly braces, because now it's ready for me to write code. Ready for me to do something to make that behavior do what it's supposed to do. Now this behavior is supposed to do what? Output current value. So what do I probably do in there? I probably see out what?
The values.
The value, right? Value underscore.
From the
right?
attributes.
The current value of an attribute. Does that make sense? Right? So you try to name them well. Right? Try to say what they do. So the first word, the return type, we'll get into return types next week. Right? We got a lot to do next week. I keep just pushing things off. Right? Yeah. A lot of everything we do today will be void. Next we have the name of the class, right? So math. Then we get the 2 colons, which is called the scope resolution operator. You won't be tested on that. That's what it's called. All right.
Is part of operator?
Right. It's the is part of. Yeah. Exactly. And then class name is the type qualifier. You're not going to be tested on that. So I want you to know there's some return type, which is any type plus now a new type called void. But it could be int, double, char, string, bool. Can't be math. We're in math class, right? And then the class name, colon, and then the function. Right? And then you always have parentheses. And we'll learn to put stuff in the parentheses, but not yet.
Those would be your.
When will we learn that?
Next week.
Next week. Good.
Shit.
All right. So
Don't get sick.
return type, class name, colon, function name, open close paren. Because function name doesn't end, because the parens don't change, because this void keyword doesn't change, this is the only time where I will suggest you copy and paste. Because if you mistype output current values, right, if you make that a lowercase c, then the program's not going to compile. All right, so this is the only time where I highly suggest you copy and paste. Make sense? And I'll teach you the easy way to copy and paste if you don't want to use it now. All right, sound good? We can do that? Yeah, we can do that. The beauty of objects, the beauty of class functions is that as a member function, they have access to all the other members of the class. Right? So the output current values function has access to all of the attributes of the class. The attributes of the class are what? Value underscore and
extra input.
Right? So it has access to those. It does not need to create them. It does not need to figure anything out with them. It can just use them like it can use any variable that you created. Right? So you don't need to redeclare them. So if I have those member names, right, I can do things like cout value underscore and L. Right? Another typo. Where did behavior come from? I don't know. Ignore that. Just say math, right? Math. Right? What am I trying to say here? In this member function, right? This member function is part of the math class, so it has access to all of math attributes. So when I cout value underscore, it knows the value of value underscore and it will output. Okay? This is where, oh, go for it.
Member function is that value?
Yes, member function.
Class. Are we math?
Right, this should be math. And this is my attribute, one math. Okay? This is where things get complicated. I'm still making the blueprint. Right? So what value underscore am I output in there?
We haven't stored anything yet.
Right, but not even I haven't stored anything. This is just a blueprint for an object later on.
Because you haven't done the math object.
So I haven't created the object.
value.
I haven't created an object that has a value underscore. Okay, so sometimes it'd be hard to write these because these are blueprints, right? They don't actually have any values. We're saying this will work for any object with any value. Right? So a lot of times when I write them, I just make up a value.
So you're creating a
value underscore in my head is
function.
100, right? And then I'll try to figure out how would I write the code to deal with 100.
So that's a function so that you can output value whenever you want.
Right? With any object that is of type math. Right? So I could say math object output current values, or I could say what?
Other
Other
object.
object output current values.
As long as it has the blueprint that you're using from math
Yes.
with the value. But you can't just output some random thing. It has to
the
be
only
part of the
two-
attribute.
The only two variables that exist for me right now are the attributes, value underscore and
Extra input.
underscore. This is like main. I can create more variables if I need them, and you'll see me do that, like, 'cause I'm gonna write a for loop in a little bit, I'll need to create more variables, right? But the only two variables that I have that everything is shared in the object is value underscore and actual.
We create our concept.
Yes, math becomes a keyword that you will only use as a type,
But it just, math will only be a keyword in math, it's not always a keyword.
just in that program. Just like CM Reader now is a keyword when you bring it into your program.
You text functions.
Not really, and there's not really a good reason to. Each function will be its own distinct function. We can call functions from other functions. And call functions is the idea of we want to execute, we want to run this code. Right, so I think
Yeah, it's like a big sin.
And you can do that, and we
Nest
will do
functions.
All right, you ready to type some more or watch me type some more?
Sure.
Why not? All right, I told you I'd teach you how to copy and paste the right way. Right, you guys want to see how to do this? Right, so
Let's see.
I want to define what that function does, right? I want to define the output current values function. Okay, to duplicate it, if you don't want to like highlight it in Control C, you can in Cloud 9 Control Shift D. Control Shift D for duplicate will duplicate.
What?
Okay. Now I told you that you write this below main. So you hold down Alt and then you use the arrow keys, it will move wherever you want it to go. You can move it all the way to the top, which is not where you want it to go, or you can move it where? All the way to the bottom. A little bit more space here.
What sorcery is this?
Right? The less you have to use the mouse, the faster typer you will be. Right? Not necessarily the faster programmer you will be, right? Your brain still has to think faster than your fingers can type, right? But the less you have to move the mouse, the better off you're going to be in programming or anything. Right? Now, I have to do something to this though, right? What do I have to do to this? Everything.
Scope resolution.
All right, good, right? That is part of, good. What else do I need to do?
You need to put the prefix to that.
The prefix for this, which was what? Math, right? And it's math because, well, let's go look real quick. The name of my class was math. And notice there's curly braces here, so everything inside of there is part of the what class? Math class. Good, right? So math, colon, output current value. Anything else? Parentheses, but not just add parentheses, but also get rid of semicolon. Like get rid of the semicolon and convert it to curly braces. No joke, I never joke. All right, coded assignment 3A is literally doing that, just multiple times. Right?
Sick.
I want us to get really used to what? Copying it, adding the class name colon before it, and adding the curly braces in replacement of the semicolon after. Cool. Okay? Once we get that ingrained, right, then we can deal with all the logic. Right, but I want to deal with the syntax, right? Let's get the syntax set up correctly. Once I have the syntax set up correctly, then we'll fill in the code, the logic later. So that's why there's a coded assignment 3A, work on the syntax, and there's a coded assignment 3B, work on the logic. Okay. Don't freak out. 3A is due next Thursday, and I'm not even going to talk about it until next Tuesday.
Oh.
Okay. You're welcome to look at it and try to complete it. Just realize it is not like the shooting game. There is not any logic to it. It's literally, can you follow the pattern? If you can follow the pattern, it's going to be super easy. Make sense a little bit?
So we're doing this under int main
Yes, I am below int main.
for a reason?
Yes. Because we're going to eventually put it in its own file.
Sorry, I did, if I'm
No, you're
jumping
fine.
around.
No, not its own file.
Until next week.
week is everything.
I think that's the week after, actually.
Oh, well, no, the week after that, spring break.
So you're not coming?
Oh, no, I'm not coming to spring break.
What's the week after that?
Okay, yeah.
I love spring break, and I also hate that, like, you like do spring break, you're in the groove, and you know what's going on, and then we come back after spring break, and you're like,
Spring.
what's it called? No?
You're right, I'm gonna be working.
What is
Remember
a
what you're
semicolon?
supposed to do instead of me scrolling? You can always go ide.c9.io/lookatView/PA1SP18, and you can have it on your own screen.
Ew.
That's a big deal.
This is super distracting.
Yeah, you found out.
You gotta figure out who that is. Gotta find who's this person?
I'm not highlighting.
Is it Ethan?
Denzel.
No, he's not doing it. Someone else is doing it.
It's the pink one.
Oh, it's the pink one. Uh-oh. It said, you know what? They don't have to run around. You good? You good? No. No, this one's not in our contract. Manny, is it you?
Well, I don't even want it yet.
All right. No distractions. All right. In main, right? Oh, sorry, not in main. In my function, I can see out, right? Value underscore with a new line. Right? See out value underscore in a new line. All right. What is the value of value underscore? Once again, we don't know. Right? That's key. We do not know that value.
Well, we set it to 42 earlier.
I set it to 42 in the math object. This, did I say math object anywhere here?
Okay.
No, and I will never use the name of an object here.
Okay.
Right? Because this is the blueprint. So yes, when I call this function on math object, then it'll be 42.
Okay.
But if I call it on a different object, it'll be something totally different.
So this
That's
function's
the
name is
concept.
output current
That's the
value.
name.
Okay.
All right. But I can now, instead of outputting math object, notice here in main we said see out math object dot value in line.
Yeah.
Right here, what did I see out?
Value.
Value underscore. Did I say math object dot value underscore? No, because once again, how many math objects can I make?
As many as you want.
Right, I can make as many as I want. Right? You can create as many objects as you want from the one blueprint. No, not an array. If it's an array, that's just
Array
Well, I
has
remember
the hard
six
bracket.
objects, six variables.
I remember arrays
It'd just
now.
be like saying int a comma b comma c comma d. But now instead of doing this line of code, right, I can actually say math object dot what output current values. And don't forget, always open close paren and a semicolon. All right, this is the first time where we're going to jump code. Okay, this is called calling a function. When I call a function, right, and I know it's a function because what's on the end of it?
Parentheses.
When I call a function, I leave wherever I am in code. Right now I'm in main on line 20. I leave that and I go to the function named what?
Output current
Current value, right? So I go from line 20 and I go down to line 29. 29, good.
That's
Next line of code says to see out value underscore. How do I know what value underscore to output?
Well, you use math object, so you can use that blueprint for
Right.
42.
I said that this function is going to run on that object. So whatever the value of math object's values are, those are now the values in my function. Does that make sense?
It's making a lot of
Right?
sense.
If I said, and I will, right, I'll do it. Don't tempt me.
The balls you
If I
want.
say e dot output current value, right? That will also go from line 22 and jump to what? Line 29. But now when I see out value underscore, what's that value?
Nothing.
Garbage, right? Yeah. We don't know what it is, so it's garbage. That makes sense? I can use the same blueprint, right? Function definition for many different objects. Because they will all act on that object's values.
So we could
And I
have.
want to show you that in the debugger so we see it.
So we could have. Can we put inside there that like? Okay, so say our game we just did on our assignment, we kept having to call the random number. Could we have put that in there as a function to then be called whenever, so we didn't have to do the whole operation every time? Okay.
For sure. When you make it object oriented, you can have the value of like computer's guess and user's guess be attributes.
Because
And so every time I want that attribute to change, I could call a function and it will change the attribute. Which is really nice. Really slick. All right, let's debug it. All right, I want to do a breakpoint. I'm going to add the breakpoint, save the file. All right, go over here. Turn on my smash bug and run. Whoa. You guys can see that? Is that big enough there? Right? How many variables do I have?
6.
6 variables, right? Notice that next to those variables, does it say any of them have values?
No.
No, but what do we see next to the variables?
Their names.
Their names, a diamond, and then what? A triangle. What do you think the triangle means?
To see where they're at.
Open and close, right? We can see, so I can open up the A object, it's an object, right? And inside of that, mystery word, public. Right, inside of that, what do we see?
Garbage values.
Garbage values, extra input underscore and value underscore with garbage values.
2,764.
Right? Because did I give A any values?
No.
No. And in fact, have I even given math object any values?
Not at
Input
that
0.
point yet.
And
Not
value
yet,
is
right?
4,096,000.
Notice I'm on that line of code, so it should, after I run the line one time, right? It should say value underscore gets 42. But only in my what? Math object, not in objects what? A, B, C, D, and E. They're all their own variables, right? That should make sense. If I create two integer variables and I change one of them, does the other one automatically change?
Nope.
They're their own distinct variables. Just like with object-oriented programming, they're their own distinct objects.
So like their A, B, C, D all are their own objects, but
All their own objects,
but
but
their
all their own
blueprints
values.
haven't been filled out yet.
Right. And now if I go ahead and step this line of code, right, it's really annoying that it closes it for you, but if I open it up again, you notice that value underscore is now what?
42.
42, we got the right value. All right, if I do it again, then extra input becomes
0.
I think 0, right?
Oh, why do you have to keep doing this?
Super annoying. Does it make sense so far?
Yep.
I've got a bunch of objects, but I'm only messing with one of them, right? And it knows I'm messing with the math object because I'm using the name of the object and then the dot operator and then the name of the attribute for that particular object. Right? How many extra input spots do I really have? 6. Right? 1 inside of each of the objects that I created. I created 6 objects. Each of them have an extra input attribute. So there's 6 integers I can store there. They each have a value underscore, so there's 6 more integers to store for each of them for value underscore. We got lots of space to store stuff. All right, I'm now at what we call the function call. Right?
Is there a way to store values in all of those more simply than to have
No.
math object dot blah blah blah?
Well, we can give values at creation time, which we'll learn
next week.
next week. It's all coming. There are so many cool things you
There's
can do
no
with
scientific
objects. The
evidence that winter is
person familiar
coming.
with just like creating basics.
It's crazy because like my final last semester, my whole game was like object oriented and prototype. So like I'm like I see it and trying to
But it
translate
looks a
it.
little bit different.
Yeah.
It's a little bit different, right? In JavaScript, it's like create as many attributes or behaviors as you want, whenever you want.
Like I did the collision detection there. It's like
All right, so far when I've debugged, I've always done the step over. The one next to it's called step what? Anyone remember?
into.
Step into, right? When I do a function call, when I know it's a function call because of the parent, right? If I do step over, it'll run the function and then just continue on with my code. If I say step into, it'll take me into that function, which is where I want to go. So I'm going to step into,
F11.
right? What line am I on right now?
You're on
Highlighted one, 20. I'm on 20.
20.
And if I say step into, right, I'm actually going to go all the way down to line 31. Right, the next line of code that really is running.
Oh my god. The value of this is 0x.
So you'll notice, yeah.
E.
Do I have math object or object A, B, C, D, or E anymore in the debugger?
9 in the board.
No, what do I have? This word called
this.
this, okay?
Is that the
This
prototype
is
thing?
synonymous for whatever the object was that I called the function on. So guess what? When I open up this, the value of value underscore is going to be, wait for it,
42.
42, which is the value of which object?
The math object.
Math object, because on line 20, when I called output current value, I called it on which object?
The math object.
Math object. So this is, right, the object that I'm dealing with here. So when I output value underscore, it's going to output, right, this is value underscore, which is
42.
42, because that was the object that I called the function on. That make sense? That was the object I called the function.
Do we ever use this as a keyword in C++?
You can, but most of the time you don't. Java uses it all over the place.
That's what I was asking.
But usually in C++ we don't have to.
This is like the way of doing it. Okay.
You could, instead of saying value underscore, you could say this arrow value underscore.
Oh, sick.
Right? But that's just more typing. Who wants to type more? Nobody. Alright, anyway. So if I keep going, right, the function ends, right? I hit my closing curly brace, my function ends, and I go back to, right,
The last spot
next
you were at.
line, right? So I go back to the function call, and then I continue on with my program. Right? This time, line 23, I'm gonna call output current value again. Is it gonna output 42?
Probably not.
Probably not. Let's look at what just got output. Let's make sure it was 42. Everyone see it? 42 is outputted?
Yep.
Why is this one not gonna output 42?
Because we don't know what E is.
You didn't assign any blueprint
With
values.
its own values, right? Which currently I think are garbage, right? So I'll put whatever those garbage values are. So we can go into that function. Notice I get the same word, this, right? But when I open up this and I look at the values, right? Those values are garbage values.
32,767.
Those were the attribute values of the E object, as opposed to the math object.
So you step into that.
Yeah, if you step in, it'll take you into it. Right? And then I'll jump over it, right? And then return 0. You'll notice that my output was negative 7,550.
Yay.
Good question. So the question is, how do I know which value? It's all dependent on what we call the calling object. So output current value was called on which object?
E.
This was E dot, that's how it looks. This was math object dot, that's how it looks. Remember, when I wrote this function, I had no idea what the names of my objects were going to be, right? I just had to write a blueprint for any object. How would I output its value? I would just see out value underscore. I don't know what that value is, I just know that's the blueprint for what I use it. Okay. Good so far? Any questions? We're gonna stop it. No more debugging.
Okay.
Hi.
Give it our breakpoint. All right, I'm gonna write the other two functions real quick. All right, the sum2 function and my extra or my raised to power function. I'm gonna write them real quick, and then talk about them.
Are you just gonna use the same page you're on right now?
Yes. We're gonna write two functions, and because we haven't learned how to do anything else, I'm gonna make them void functions.
Are these still in your class math public thing?
Yep.
Yes. So I'm gonna write a function called sum2, and we're gonna write a function called raised to power. We're gonna duplicate them. The two of them is a little bit harder to duplicate. I'm gonna duplicate them, and then what am I gonna do with them? Move them all the way down to the bottom.
And you're gonna do the function part.
Yeah. I'm gonna do what you're gonna do for assignment 3B. I'm going to add class name, colon, before function name. I'm gonna change the semicolon to curly. All right, and I'm going to add class name, colon, and change the semicolon to curly. Sum 2 is not too hard to calculate. I'm just going to say the value, right, equals, right, remember we have that n over 2 times n plus 1, so I'm just going to do that. Right, but instead of n, I'm going to use extra input. So say extra input over 2, right, and then I'm going to multiply that by extra input plus 1. So ideally, if I set the extra input value in my object, I can call the sum2 function, and it will set value underscore to the answer. All right, and I will show you what to do. But this line 37, that's the code that we did in the beginning of class, right? We figured out what that code was, but I don't have to copy and paste it. I can just call sum2 whenever I want to do it. All right. Same thing with raised to power. I'm just going to type it. Right? We said int, right? Solution. Right, we said answer, but we'll do solution. Int solution equals 1, or anti equals 0. We're going to say I less than extra input. We're going to make extra input be the exponent I plus plus. All right, and then we're going to say solution times equal value underscore the base. And then at the end, right, I'm gonna say that value becomes the solution. So whenever I run these functions, right, value underscore will always have the answer to what I'm trying to figure out. Value underscore will always have the answer. And so as long as I set extra input and value, I'll have the solution, right? Same thing up in sum 2, if I give extra input and value, then I'll have my solution. Which is going to allow me to do some cool things with it. Right? So if I say my extra input is 200, right, this will allow me to say math object dot sum 2, right? And if they do this, right, and then when I output the current value, I should have the answer to the sum 2 problem. Extra input's 200, so I'm going to sum to 200, right? And so when I output it, I should get that value, which was right 20,000. All right. Let's talk about what it did. It set values in my object, right? This said go to the sum2 function, right? Go to the sum2 function and use the values of math object, right? So it went to the sum2 function, right? And it used whatever the attribute value of extra input was for math object as its thing, right? Which was 200, so it said 200 over 2, which is 100, and then it multiplied it by 200 plus 1, 201. 200, or 100 times 201 is 20,000. Right. I can go back up, right? Now I could say math object, right, dot value underscore, right, this is my base. I'm going to say my base is 5. I'll say math object dot extra input underscore, and we'll say that is 7. We'll see if 5 to the 7 fits inside of any of there. I think it will. Right? And then what I want to do, I want to say math object dot raise to power. And then I just want to say math object dot output current value. You'll notice the code in main looking a lot different. Right?
Oh yeah.
The code in main's looking different, right? Jeez. I set the value attribute of my math object. I set the extra input value of my math object. And then I said leave main, run the raise to power function, and use the values of 5 and 7. Right? That will calculate it, store it into value underscore. When I come back, I'll call output the current value of the math object, which will run to that function and see out whatever the answer. Anyone know what 5 to the 7 is? Like, no, that's what we got confused. Not too big. 78,125. Because once again, when it sees this, math object dot raise to power, it goes down to the raise to power function, right? Set solution to 1. Notice I created the variable because it didn't exist, right? And then I looped as many as extra input, the exponent, right? I took the value to multiply it, and then I stored the value. Right? So it took 5 to the 7th, because I don't know what to call that. 5 to the 7th, and gave us our answer. Good? Questions on this? How we doing?
I'm pretty good.
Pretty good. All right. Today's lab will be a little bit of a code along because I'm just into code alongs right now.
Okay.
We're gonna write what the lab is, and then I'll have you do a little bit more. The lab is broken down as like ask like question 1, 2, 3, 4, 5, or something like that. We're just gonna write the whole thing, and then we're just gonna turn in what we write. So don't turn in the answer sheet, you'll turn in a CPP file that will have everything. You don't have to worry about 1, 2, 3, 4, 5, or like that. All right, that's what we're gonna do. So I'll give you 1 minute, or 2, we'll take 2 minutes, or 3, right, to just get the lab up so you know what it is. Create a file on Cloud9, so if you're not logged into Cloud9, get logged into Cloud9, and just create a file called like card.cpp, C-A-R-U, card.cpp.
Wait, how
that
come
will make sense
isn't
why we're
open?
doing that.
I have to open it?
It doesn't exist. Right?
No, I'm talking about how this is my first time trying to go to yours because I want you
You're
to
not going to
scroll
do
up.
mine.
No.
You're going to write your own for your, that's what you're going to
I want to finish what we just coded along.
It'll be there.
I don't know how to
do it
open
in
it.
2 minutes. You can double click my file and you can see it.
That's what I'm saying. I don't. It's just blank. I thought I would pull up what you are. I have to,
Hard or math?
Math.
We just did math. It's not blank.
okay, here it is. Thank you.
There's lots of stuff.
Well, just when I. Never mind. I don't need you.
It
I
doesn't
don't
really matter.
need your
I just did
handouts.
mine on the root, so like just click on I clicked on WD1 SP18 right there, didn't send me the file.
Whoops. There we go.
See how well I did here.
I'm gonna pass out the amazing Star Wars stuff. Okay, I'll put that up there too. So if you ever want to get to mine, which could be useful while I'm typing here, let me show you. That's the URL. There'll always be that URL. And you'll have to be logged in.
Okay, so you want us to create a new file.
It's called card.cpp. Or really anything just needs to end in what?
.cp dizzle.
Oh, computer please.
Right, it's only going to go with, right, so it's only going to be one.
What is this?
Choose one.
Like 7. I guess I'm gonna be the Ranker from Return of the Jedi.
There was a dead bat outside my office.
It's all your fault.
They really are, you don't want
Damn it.
I know.
Gotta be a way to put this on here.
What is this error telling
Once
me?
you're there, you should see all my.
What does it say?
Variable or field raised to power.
Object raised to power doesn't exist. No, you did. It's just it doesn't exist.
Math.cpp is the combination of the three
Maybe you spelled it wrong.
lecture file examples from today. Alright, so under class examples. The combination of them. Alright, are my 3 minutes up? Someone say yes, your time's up.
No,
We wanna go home, let's get this.
no, your
over.
time's not up.
Alright, let's look at.
Oh.
Let's look at today's lab, we're gonna talk about it a little bit.
Oh shit, it
did. That's super awesome.
Nice.
Oh, I forgot.
Alright, everyone have a playing card?
Yeah.
Alright, some of you probably play cards and some of you probably don't.
I love
It doesn't really
poker.
matter for this. Alright, we will talk about it all. So, I only give you a playing card because, right, we're doing object-oriented programming. Objects, right, represent real-world phenomena. So this is like a visual, this is what a card looks like.
Look at this old part.
Right? So,
Wait, Obi-Wan Kenobi?
if you look at your card, right, think about what attributes a card has. Right, what are kind of the key attributes of a playing card?
Color?
Its value.
Okay, we're not gonna actually make, because we're console, so we don't get to draw it, so we don't have to worry about height or width or color. The suit, right, there's 4 suits, if you don't play cards, there's 4 suits, right, there's hearts, clubs, diamonds, and spades.
Yeah.
Everyone good with that? So there's a suit, right, one of the attributes of all playing cards is that it has a suit.
And a value.
It has a value, right? Ace, which is 1, right? 2 through 10, and then a jack, a queen, and a king. Okay.
Or a joker.
Whether
In
it's
fancy
showing or
terms,
not.
that value is the rank of the card. The cards have rank,
Ooh.
right? So when I make my class, right, my class card will have a suit underscore, and it'll have a rank underscore.
We got a rounder on our hands.
Right? Now these have pictures on them, but that's not all have pictures.
feel like the like visibility of what the value and suit are could be part of that, like true or false.
Yeah,
You
like
can
it's
see.
flipped or not?
Yeah.
Yeah, that would be if we were like gonna take a card object and have it integrated into a card deck object.
Ooh, so they're talking to each other.
Exactly.
It all fits together.
I think I just like you could, right, that would have to be in the blackjack class, right? Today, we're only gonna create what is a playing card, and then you can create one-to-many playing cards. We're not gonna create the playing cards and make them into a deck, and then figure out how that deck is used in a game. I don't have time.
He's down, but he doesn't have time.
Right, so, notice question 1 says, write a definition for a class name card. Class is gonna represent a playing card, good, right? So, it has an integer to represent the number, the rank, and a character to represent the suit. So let's do that first.
Okay.
All right, so I'm gonna go over to my.
What is this, 510?
Yep.
Where's my card, Larry?
You don't know.
What? I said, you don't know.
Aha,
You're not going to be part of the system.
here we go. Here's my card class, right? I'm going to include.
What the heck is that?
Include.
Ian include.
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 Right, if it changes colors, then we know we're good, right? We're gonna include IOStream, right? We're going to.
Is that any way to live? If it changes colors, we're
Yeah.
good.
Using STD and L, using STD CN. That would be it. If I need more, we'll do one. In main, we'll return 0. Right, if I was gonna write a declaration for a card class, where would I put it?
Before main.
Before main, right? Trying to be easy questions, right? Class should be called
Class.
card, right?
Or that.
Open curly, closing curly, semicolon, right? Special keyword, mystery keyword public, right? And we're gonna deal with the attributes of a card, right? And we said that there's a rank, which is stored as a what? Integer. I'm gonna say integer rank underscore. Right, and I'm also going to say, I told you the suit, we're gonna store as a character. You'll know why here in a little bit. But this is a class. Does it have any behaviors yet?
No.
No, it only has attributes, right? Which is enough for us to get going on what a card is. So in main, you have this. In main, what you can do, right? In main, you can say card, right? My card. Or this is my card, not your card. Right? If I want to get a rank,
Excuse me.
right? How would I give my card a rank? What would I type? Would I just say rank underscore?
No, you do my card, my underscore card dot rank.
My card dot
Rank.
rank underscore, right? Now, you have a card, right? So my answer is not going to be the same as yours, unless you have a king. Mine's a king, which happens to be a 13. Right? If you count up, 10 would be 10, jack would be 11, queen would be 12, and king would be 13. Right? So I might get a 13.
I got an ace.
Right? If you don't have a king, then you should put what you have. Right? Trying to represent that all of us can have our own card objects, right? They are not the same. We each have our own separate cards.
Got an ace.
Right? And then the other thing I do is my card dot what? Suit. Right? And then right, I have a spade, right? So my suit, because it's a character, would be inside of single quotes. Make sense so far?
Yep.
Right? That wasn't a lot of work to make a playing card. I didn't do anything, but I have represented a playing card that
Thanks for
has
crushing
a
my
rank
dreams.
and a suit, which are the default, or the simple attributes of a card.
You haven't controlled the states of which one's winning and
Right,
any of that
who's
yet.
winning? I don't know which one's bigger or not, right?
That would be a state.
Now, ranks I know, but if they're equal, I don't know. Alright, good so far? Everyone good with that? Right, can I see out my card? You can be like, sure, and then you try to type it out. Actually, you can't do that, right? You can say my card dot what? Rank and my card dot suit. right? Now, anytime I want to see the playing card, I'm going to agree that I have to say see out, my card dot rank, my card dot suit, right? Agreed?
Yeah.
And so I'm going to wrap that up in a behavior. Right, because anytime I want to output a card, I just want to say my card dot output and let it do the work. That makes sense? Right? Also, like anytime I want to get a rank and a suit from the user, I have to like write some CN statements to get it. Right? That's also something I might want to do multiple times. And so I'm going to add another behavior to my card class, which is how do I get input? Make sense? So my card has a rank and a suit, those are my attributes, and my card is also going to have input of the card's values and output of the card's values.
So you can have a function that asks the user for input?
Yep.
That's freaking rad.
I'm going to do it right now. You ready?
Yeah.
All right. I'm not going to use CM Reader so people can screw it after that. All right, let's go up here. They are functions,
I'm on my way.
right? So those are the behaviors of our card, right? Right now they all start with what word? Void, right? Are you going to call one input? Actually, is that what I make you call it? I call it set. All right. I just want to deal with the same that I said it in the lab. So I'm having one called set, and then the other one's called output. These are like the easiest functions to write. Void means they don't produce anything, and the empty paren said they don't really get anything. All right, we're going to change those out to make them more complicated, but these are the simplest ones.
Is there a reasoning for the indentation offness of public that you would go into, or?
Well, so we always end it 2, and public doesn't really need to be its own 2 and everything else be 2 more, so we just sneak it in by 2.
Okay, got it.
Because it's just in between 0 and 2. That's the reasoning, whether it's good reasoning or not. I don't know.
Oh,
All right, what am I going to do here?
Yeah, me too.
What's my next step?
When you
Oh, you need to go to the bottom and you copy paste them all down.
Right, so I'm going to copy them. We're going to go down to the bottom. I'm going to paste them in.
So when I duplicate it, I always have to like split the lines up again.
You have to make sure, if you're going to do multiple lines, you got to make sure you highlight both lines.
Oh, like alt highlight?
Then when you duplicate it, yeah. You hold down shift to highlight multiple lines.
Excuse me.
Okay. Let me compose myself again. Class name, colon, semicolon to a what? Curly. If you learn anything this semester, this is what you're going to learn. I'm just going to keep saying it over and over again.
Should we do card?
Yes, I should do card because the class is not called math. Good catch. There we go. All right. All this just so I can actually write something, right? I haven't really said it does anything. I just said it what? Will do something. Right? That's all I really said. No.
Nope.
Only in the class decoration, but no semicolons. All right, good question. So set is going to get it, right? And so anytime I ask for input, I should first do what?
Prompt user.
Prompt user, right? See out. Please enter the rank of your card. You don't have to be as nice with me if you want me to be mean. That's fine. Right? CN statement. Do I say my card dot rank? Is that what I say? Is that what I would say?
Wait,
Yep.
what is it? Yes. No.
No. Why not? Because this blueprint should work for just my card or should work for all cards?
All cards.
Right, so I can't qualify it with a particular object because, right, it needs to work for all objects created. So I just see in rank. Right, once again, that rank is a member name and it exists because in my class, right, I said that there was something called rank.
Yeah.
Does that make sense a little bit? All right, so that's one. All right, and then I just have to do the same thing, right? See out. Please enter the suit. All right, and CN what?
Just suit underscore.
something I haven't done a great job of is I probably should have already compiled like 2 or 3 times. Right? When I wrote the class declaration, I probably should have compiled. When I copy and pasted and they were empty, I probably should have compiled. Right? Once again, compiling often limits where your errors are. Right? So I'm going to compile now. I don't really need to do anything. I just want to compile to make sure that I don't have typos. When I run it, it runs, processes with code 0, right, which means the syntax of what I've done works. Right. Sorry, I should have done it earlier so you didn't know where it was.
What did I mess up on 10 pages later?
So now, instead of giving it mycard.rank and mycard.suit, now I can just say mycard.set. If I run that code, mycard.set, now it's going to say please enter the rank of my card, right, 13, right, and enter the suit. I'm going to do S for spades, right? And I could do that for any card that I created. I could say mycard.set. I could create a card called your card, and I could say your card.set, right? Or say card 1 equals, right, card 1.set. What did I do? I did in main, right? So I just changed main from mycard.rank underscore equals that, and mycard.value underscore equals that. So just mycard.
Holy errors.
Yeah, bully errors, then there's probably something with baby.
It's telling me like line 13.
Let's wait for the top.
Oh, huh.
This is the only one that has a semicolon.
All right. I'm going to write my card.output. I know some of you are still catching up. Remember, these will be here. You can copy and paste them over your stuff too. And look at what we're doing. So output's going to output my card. Right? So I'm going to say, well, right? I'm going to say cout, right? Rank, which is the number. So I'm going to cout an of with some spacing. Right? And then I'm going to say suit. We'll slap an inline on there. So if it was 5, if rank was 5 and suit was D, it would say 5 of D. Right? If for me 13, it would say 13 of X. Right? So I'm going to run that. No, that's a lie. I'm not going to run it. I'm going to go up to main and make sure that after I mycard.set, I'm going to mycard.what? Output. If I don't call them in main, they won't happen, right? To activate a behavior, I have to call it in main, right? On the object that I want to activate it on. Well, here, I'm going to run it. No, print.
Instead of using a character, could we use a string?
Yes.
But we have to include it on the...
Yeah, and I'm going to show you why I'm not. We're going to get there. I'm not using a string on purpose. There's a method to the madness that is used, right? So if I say 13 and I say S, right, it says, quite boringly, it says what? 13 of S. What do you think I would want it to say?
Spades.
Spade instead of S, so here I want it to say 13. I probably want it to say what? King. Okay? Remember I told you you were going to have to do a little something today for your lab? I can't just spoon feed you everything, right? I could, but I'm not going to. What I want you to do is work inside of that output function, okay, for it to say the correct things. So if it's a 13 of S, it should say king of spades. If it's a 1 of D, it should say ace of diamonds. If it's a 5 that is a club, it should say 5 of clubs. Which means what are you going to have to use inside of that? Right? If else statements. Right? You're going to order them in the correct way. Right? And for those that don't play cards, I'll kind of help you out with at least what they're going to be.
Oh, those have to be in public.
Kevin, yeah.
So we basically have to make if-else statements for an entire deck of 52 cards.
Good question. Do I have to make if-else statements for a deck of 52 cards?
Nope.
No. Because if it's a 5, do I need to replace the 5 with something else?
Nope.
No, right? So all the numbers in between, 2 through 10, I don't have to replace. And then I only have to replace the numbers of what? 1, 11, 12, and 13. Right? That's just for the number, the rank, but it doesn't matter what suit it is, the rank will always have that substitution. You have to do that, then you'll say of, and then you'll need another if else statement to handle the suit. So you don't want to say if it's a 13 and it's a D, right? You just want to handle if it's a 13 first, and then later on you want to handle if it's a D.
What if you did like a switch statement? A whole bunch of
Switch is fine too. Switch or if else's. It doesn't really matter. You'll still get the same things. The only worry about switches is that they don't work on strings or doubles, so we don't have strings or doubles. If you like switches, you can switch. If you like if else if statements, you can if else. Alright. For those that don't play cards, a 13 needs to be replaced with
King.
king. And a 12 needs to be replaced with
Queen.
queen. Right? And 11 gets replaced with
Jack.
jack. And a 1 gets replaced with all the base cards. And then 2 through 9 gets replaced with what? 2 through 9. Right?
Oh.
That's your else.
Okay.
Right? If it's not any of those, then just assume it's the right rank and output that rank. Okay? D becomes what? Diamonds. H becomes hearts. C becomes clubs. And S becomes spades. Basically, what you're writing is a simple substitution, where you substitute a number for a word, but only in certain places. And then you're going to substitute a character for a word and all this. That makes sense a little bit? So your code is not going to have a cout statement that says, let's go back to it. Oh, I'm not sorry. You want to see it? There it is. Right? You are not going to have a cout statement that says rank of suit. You're going to have a cout statement that, right, if rank is 13, cout king. Right? Then after that if statement, you're going to just say cout of. Right? Because that's the word in between the rank and the suit. And then another if statement, right? If suit equals C, cout what? Right? But then those need to be more.
So that same would have to come first, right?
Which one?
That one. Should that be the first statement or should all that come first?
This will just go away. You're not going to write this at all. You're going to break it up. So you're not going to write that, right? You're going to output the rank inside of your switch or your if else statement. Then you're going to output the word of, and then you'll output the suit inside of your switch or your if else statement. You're going to replace that. That's your goal by the end of class today. You have a half an hour. Your goal is to replace rank with the rank, and your goal is to replace suit with the suit. This make sense? Right? If you need this code, if you didn't catch it, right, here's the link to it again. Right? So that link will get you to the code if you need that as the basis for when you get started. Okay? If you finish it, which you will, right? When you finish it, you just need to download that card.cpp and then upload it to Canvas. Okay? And ask for an answer sheet, but don't put an answer sheet. Yes. Finish it so it's saying king of spades or ace of hearts, right? And then upload that to Canvas. Sometimes people ask me, how do you get it down from Cloud 9? Right, to get it down from Cloud 9, the easiest way is just to right-click it and choose that. Right, notice I am not right-clicking the whole folder. I'm not going into File download. Just click the file and say down.
Will Canvas even let you upload that much?
It won't let you upload the zip. No, it goes down to the zip. I don't do it. It's an extra step I don't want to do.
I have to help Luke.
Sure. Not in card set, but in card output. Sign in the sign sheet before you go. once I find it and pass it around.
Go to do this when you go to window. Actually, sorry, go to view.
But wait, how can't you, okay, you have to convert. If it's a face card, you have to convert rank to player.
You're fine, if you don't want to. It's good to do, but, go to layout. And try just like, let's go. I don't know what they want.
Oh, nice. Thank you.
Here, hide mouse.
So you have to be converting your to string.
You're not gonna convert it to a string, because you're not storing it. You're just outputting it. So if rank equals 13, C out.
Oh, ha.
You don't have to store it.
Yep.
Is that out? Did anyone not get their test back?
Yeah, you So, you get to keep it. Do you have any questions? That's fine.
Just make sure it is. If I give you like a 39, so
No, the directions specifically say you need
already March 8th.
Oh, yeah.
How gross is that?
2018 is flying.
After assignment 2, these if things are like.
Yeah, come on. You only make me do 5?
I thought we were here to learn.
Right, come on. Practice makes perfect. And then just make sure I get my cards back before you leave. The only way I get street cred with my student learner.
Oh, my God. Luke is
So really all it is you've just watched Rounders 19 times. And your favorite snack is now Oreos.
I get this beautiful food.
Wait, why didn't it give me a... There we go. I think I need to add to this, but I'm just getting this part done.
Right, an item, right? You need like an item being on it. Prize, right? But not necessarily. Although, again, price seems like for all. You don't know if I'm that great.
I'm working with perfect here. And I was wondering for specifying suit or whatever that we make suit class.
The suit's here.
Yeah,
The suit is the character. So you already have
so
that.
I can just define a character range.
No. You can't limit it, right? We don't have anything to limit the usage of that. You want?
My turn to run this and see if it works. Nope. Wait. 13. It's a king. Shit.
Russell's gonna help out too. He's in the algorithm 2 class.
Shit.
You can't do all, you can't do, you have to say, if you wanted to do something like that, you have to say if right equals to or you don't know. So
I'm gonna end up making a million if statements.
because if it's not 11, 12, or 13, then it's one day. So this one is 24. And the else is 2. The else is right. The else is if it's not this and not that and not that and not that. Because if it's not an 8,
Is it my card? Is it in my card? Or is it just rank?
So we don't have to do.
Because you don't want to write one mistake. You don't want to rank underscore, or is it my card? I just write. But it's not. Well, else's don't have conditions. So you really want to do the 1 and the 11, 12, and 13. Do all those first. If else then see how it is. Else if rank is 11, see how bad. Else if, and then else if, just see how bad. Just put it has to be at the end because it's the else. You don't need to do it. You don't want an invalid, right? You don't want to say key of, and then you use another experiment after. So you have 2 distinct if statements.
So the end lines
one
in our
handle the suit and one to handle the.
end lines in our if statements are wrong.
Well, you don't want in the middle. Because I want to say king of spades. I don't want to say king new line. New line. Spades.
Okay.
Unless you want to be dramatic.
No. So how do you do that? You just
Just don't put end line at the end of the CL.
so what do you do? Just close
Just a
and
semicolon.
done?
Yeah, you're done there.
Oh shit. No wonder. Damn.
Alright, okay, so in main,
Yeah.
right, following my card dot set, now you want to call the output. That's almost like, crawling a function is like run this command. I want you to run the code inside of this function.
And then do I have to put C out in my card?
Nope, because you see out in the function.
Damn it. Rank was not
Exited with
declared in the
Right,
scope.
you're gonna jump
Yeah,
from
about
there.
that same area.
What does that even mean?
It's not under any name, I'm guessing. It is, it doesn't say in the middle, it says it.
And then you could go, use those functions, and then continue the program with others, using that.
Okay, this is crazy.
Yeah.
I don't even know why it's not doing anything.
My card output 1 is not defined. Oh, it says member function declared in class card. Oh, got it. Okay.
There you are.
I can do this, but it's gonna make me write a
Does your
million
if
if statements.
statement need to be, it needs to be in main.
The if statements?
That's what I'm pretty sure, right?
I'm putting mine in the object.
Output of the card class.
The object. Or output.
Well, not erase it, because, well, you want to keep it. Because, think about it, it's not a one-on-one book, we even have to say that it's 5. Appreciate it.
No, I didn't get my question answered. I just saw something else I'll have to fix, but that's just a string thing.
So, you're writing it in main.
Isn't that where, I thought that's where we've always written our if statements?
Right, but now we're gonna write them in the functions that deal with what we're trying to do.
Okay, so how do you decide which one's which?
Well, basically because you're writing code that will work for all cards, which means it needs to be in a function of the card class. You're writing the behavior of output, so it needs to be inside of output.
Okay.
Right. If you were writing something to deal with the object, then you would write it in main. But you're not dealing with the object, you're dealing with the
So if we were writing my card dot rank, then it would be inside.
Right, yeah, if you said if my card dot rank equals that. But we're wrapping it up in an output function that works for all cards. Okay. So that's why we're doing it. And then you can't have it no conditions on else's.
Oh, it doesn't even get, okay. I did it backwards then.
Yeah.
I knew it was one of them, but I did it backwards.
So now if we said it was a 12 of S, it should say queen. Right. That's from that scale statement that you have.
Right, yeah, I'll have to fix that up.
But then the good thing too is that if it was just a 5, right, a lowly number, right, then it still says 5.
Why is it saying 5, 5?
Well, because you didn't say rank of. So it's just then rank and then rank, yeah, rank 2 5s. But all the other ones you said ace of space. So here you would have to say rank and then do an insertion operator and then in quotes say of space. Does that make sense? You're almost done. How do we submit this? Okay, just right click on file. This is kind of like another hint thing.
Yeah.
And then put that up. Oh, okay, right on. Yeah, I'll put like that. Okay, sweet. Oh, yeah. Okay. Let's see. Oh, those are just in characters. Just like that. Oh, like that? I was just gonna make the same thing. I guess. We'll see. Oh yeah, but that's because we were using time. Oh, okay. So you only need, yeah, pretty much you only need to see time if you're dealing with it. Okay. If you're doing something. Thank you.
Is this over commenting? I'm probably over commenting, but I need to figure out what I'm doing.
No, I mean, that's fine, but we like to put our comments above. Otherwise, the puzzles gets hard.
I don't get why it's going queen 12 of Q.
So, how do we upload this one?
If you go in the assignments where you click begin assignment, all I did was copy it from there and save it to the C++ file, and then upload the C.
So that's my mistake.
Oh, that's fine.
What the hell?
Yeah, like the rest of
Hearts.
That's what I'm doing. Queen of hearts.
Right.
We have to make it four hearts. For the suit, I think it's making you get like the
Where's the sign sheet end up?
Oh, it's good. It's right here. It's moving around. Sorry, I'm so focused. Oh,
They say geniuses get screwed.
true. A compliment I gave myself.
Falling apart, be like, I'm just a genius. That's my problem. But yeah. Well, the rank is one case. Well, the rank of health statement is different than the suit of health statement. Yeah. So like take. So they're out. And I think I have to be out. If suit is out.
Actually, going back at goes to Seattle.
Before. I go back at enter function.
Yeah, when you suit.
No, not suit. You want to do a suit. You still have.
Yeah, you have to wait.
There's no else's. It should only be one of the four. There should only be class A.
So if, else, and then. No, you don't have to have one.
It's optional.
Oh, you guys do it? Congrats, man. I'm right behind you. I have one more.
Main broker, the sign-in sheet.
So we got spades, hearts, clubs, and diamonds, right? See out. What is that? Like check for that or that's seeing reader stuff. And he said don't. I think he said don't even worry about seeing reader. Right? Right? Oh no! What did I do wrong? Disgusting. Hey, let's do 13. And H. King Hearts of H. What did I do wrong?
What?
Oh, this needs to be different. You put yours at the top. They work.
No, I think someone's funny drop.
King Hearts 13 of H. What?
Yep, that's exactly what your card is.
What
It's so
am I
broken.
doing?
It's so broken.
Yeah, that's fine.
White tea time. Someone's ahead of me.
You don't need it if you want it to look nice.
I
I think I'm hitting a logic barrier.
King, hearts, 13 of 8. Okay,
Something's wrong.
yeah, it's all about timing, right? If you think about it, I'm gonna do spaces on purpose, right?
Right.
This if outputs the king,
Mm-hmm.
right, or the queen, or the number, right? And this if outputs the suit.
Mm-hmm.
But between those two, what do you need to output?
So can I split this up?
Yeah. You only really
Yeah, I guess.
well.
It has a C at the end.
Did you misspell it? You're probably still outputting suit somewhere.
At the end, when you're supposed to.
I know this isn't.
The last C out.
If you think about it, you're gonna see out this, then a space,
Yep.
then a space,
Yep.
and then one of those. And now,
Space.
now it'll look beautiful.
I think I got it now. It's not gonna be King Hearts 13 of H.
Queen of
Yeah,
clubs.
test it with like a,
Okay, I got it.
11 or something like that.
Suck it, nerds.
Got it. Now we just copy this and put it in a file.
Let's go 4 of let's see.
You can see how it's right here.
Oh.
14. What did you get?
Let's try it.
It makes sense to me. So
14 of Q. Let's try 14.
Get 14 because that's the else.
yeah.
14 of Jack shit. Yeah, well, I used Q, like not a letter that you can. Yeah.
Broken? Specific?
So download.
Oh, what do you mean too late? It's never too late.
Kill it.
I did it.
Wait, can we just say card TDP or just download it and then.
Did you do it, damn Daniel? Did you get it? All right, good.
I win. I turned it in first.
I already turned mine in.
What? I opened the file instead.
Hey, good yet?
No. You have a win that I don't.
You're four? Getting dirty, bro. We should try some duos. Maybe tonight. You work?
Fortnite is gay.
You don't work? Copy it, and then we gotta look at the copy. Yeah, clock it there, over there, check how you do shit.
So I'm puzzled.
Not that one guy.
Done, Daniel.
He wasn't good. Not the guy that I saw, right? Who was that another friend? Yeah.
Nobody plays PUBG or Fortnite alone. Nobody does.
Unless you're a streamer with like 30K people watching.
Okay, yeah, but nobody. My friend was playing PUBG in like solo mode, and I'm like, nobody does that. Or any.
Oh, I get better. When I'm playing solo, I just go land tilted towers to get better.